Okay, the second question of homework 6, it uses the same gear train model that we have three gears of input, middle, and output. And we wanted to create a friction force between the three axles, meaning that the rotation between each gear and this body would have some friction. And they wanted to use a steel dry material only, so that would be easy. And then we wanted to apply some torque to the input of 100 Newton millimeter to the top gear. And we wanted to simulate 2 second, 300 frame per second with precision contact enabled. And we wanted to find the angular velocity of output gear here and the reaction moment between the top two gear here. All right, so that would be a little, might be a little challenging, but let's just try it. Okay, I'm going to open the spur gear train, and there is a mechanism. That we are going to suppress all the missing component here. I'm hoping that we have that two gear. Yeah, we do have that. So you see that motion. We have already defined this gear, and we have eliminated and suppressed the three mates that hold us in block. The gear mate is in place. That's all it matters. So if I'm going to here we have something like a solid body contact is defined and here and everything. I'm going to start a new motion study because this might not be the one that we have started. So that's a brand new simulation mode. I'm going to go to motion analysis. What was the time that is given for the entire sim? Oh, let's define it and then we'll go back to define that. So for first we have to define the friction between the axes, right? So you'll see that each of these gears have in contact with this body that we need to define a friction. So we know that we have to define a contact. So two solid bodies, it would be between here and here. And it says material only, meaning that, and the first is still dry and still dry. So between two body, no other friction would be defined, and even the restitution of the friction is not really does matter here for this one. So I'm going to hit OK. Then I'm going to define exactly the same one contact now between this gear and this housing. It would be material. Again, it would be defined based on still dry, no friction, and coefficient of restitution could be any number. Then I'm going to go back and define for the third gear, which is here, and the housing. This assembly has only 4 parts, 3 gears and the housing. And for material, still dry, no friction here, and okay. So, and then we wanted to go back and simulate for 2 seconds only. Zoom in. And it didn't say anything about gravity. I don't think it does matter much. But for time, sorry, for this one, they say use 300 frame per second, precise contact. I put it all the way down. I don't think we need that much of the precise contact, but and then we wanted to apply some torque of 100 Newton millimeter to this top gear. So in order to do torque, that's the same thing as force, just rotational. Instead of force, I'm going to go to the torque. And I select this one. Direction does not matter much, and it is 100 Newton millimeter constant. Hit OK. Now we should be ready to motion is going to move. So while this doing the calculation, after sometimes they should do that, and you see that that should start going up and up. The velocity should be increased because the torque it applies here. It wanted to find the angular velocity of the output gear. So you might see some impacts of the friction over angular velocity of the last gear. Okay, 1.5 seconds. Almost done. That was really a long simulation. Okay, you're here. If you wanted to rotate, you will see that it would be very nice and motion, and then the velocity increase. So we're not going to watch until the end. Now, if I am bringing this result, first I wanted the angular velocity, so displacement, angular velocity of the last gear, and you will see that the angular velocity should be around z-axis, right? It's rotational around z. That would be z component, and that's the part. And if I hit OK, you will see that it's gonna be give you the angular velocity of that part. Although it seems like you see there is like a cutoff here, and the main reason is because it's there is a cap to this angle, and at some point it's going to be changed, I believe. Let's look at the angular position of that and see if it is the same. Angular displacement, and let's find this one. Yeah, this is gonna be go back and forth between 180 and negative 180. That's why it's the velocity sometimes it's gonna cut off. So okay, so if I go back to the angular velocity, you see the plot. This means it meant to be all linear toward here, but essentially the reason is, you know, it's there's some limit to the maximum that it has. That's why it's going to cut off at some point. So I'm going to, that would be output gear angular velocity. Now I can select that. That would be Q2A, homework 6, Q2A. All right, and then they wanted a reaction moment between the top two gears, between this gear and here. And the reason is for reaction, you will see that again, what made really define this one, and here it should be gear mate 2. So for the reaction forces and moments, we are always required to do the mate. I'm going to go to forces and the reaction moment, and we wanted that reaction moment, even like a magnitude of that, which direction it says. Essentially that should be around z component, that direction moment. But and then we go to the mate and select 2. I will select z component and the other one. That seems like that. Let me go back and instead of that, select magnitude of that. And then, yeah. So that is the reaction moment between the two gears. And I'm going to save last part. That should conclude the question 2 of our homework 6. All right. Thank you, everybody.